So what is sound? Sound is essentially vibrations that travel through the air. It's the molecules around us moving. And what happens is you have something that creates a disturbance in air pressure, and that disturbance creates these different patterns of vibrations in the air pressure. And these patterns of vibrations of shifting molecules are what we perceive as different sounds. And they travel from the initial sound source, or where the disturbance first occurs, and travel out as sound waves. You can think of sound as kind of having three stages in life. There's the production stage, where it's actually created for the first time, and that's where there's some sort of impact or action that creates a vibration or movement. You can think of this as hitting a snare drum head or a cowbell or plucking a guitar string. This creates a vibration, and it starts to move the air pressure around it. The second stage is the propagation, or the point where kind of sound actually travels to us. And so the disturbance in the air pressure actually travels via sound waves. So these sound waves are traveling out and they run into things. Sometimes they hit things like walls and then bounce and are redirected. And other times they actually hit things that are sensitive to the vibrations, like our ears or microphones. And this brings us to the third stage, which is when these sound waves actually reach something that's sensitive to these changes in air pressure, better known as a receiver. And that receiver can take those changes in air pressure and convert them into something else. As humans, we pick up these changes in air pressure and we actually perceive them as sound. A classic analogy for sound waves and kind of thinking about how sound travels is to think about throwing a rock into a still pond and thinking about how the little ripples go out in all directions and eventually hit the shore or hit different things. If you think about that rock being kind of the production stage and then the propagation stage being those waves or ripples as they go out from that center. And this brings us to the third stage, the perception stage. The perception stage is what those waves actually hit. In the case of hearing, it would be hitting our ears. Or in the case of recording, it would be hitting a microphone. So each of these disturbances is different and will generate kind of a unique pattern of variations in the air pressure. And this is what gives a sound its character. This is kind of how we know a snare drum from a human voice. They have different patterns. So there's two characteristics of waveforms that affect how we hear a sound. There's amplitude, or the loudness, and frequency. Let's take a look at amplitude. This is the relative strength of a sound, or how much of a change in air pressure occurs. So in our visual, we can see some waveforms with less amplitude and some waveforms with more amplitude. And we perceive these differences in amplitude as essentially quieter and louder sounds. Loudness is the term that we use to describe how humans perceive amplitude. Another important unit of measure when we're talking about loudness is the decibel. And it's got two different applications. There's the decibel SPL, or sound pressure level, which is what we use to measure the strength of a sound. We've got a little list here of some of the different SPL levels, and you can see kind of how they correspond to different things. With 0 dB representing the threshold of human hearing, or how loud something has to be in order for us to be able to hear it at all. 20 dB is whispering, 60 dB conversation, etc. 130 dB, the threshold of pain. If you're at a concert and you have to leave because it hurts too much, it's probably around 130 dB. And then if you get up to 194 dB, which is really, really loud, we're talking about shock waves. And I guess kind of above that, you're thinking about stuff like the sonic boom and stuff that you don't want to be too close to when you hear because it's pretty loud. It's important to note that decibels are logarithmic, and this means that the volume changes represented by decibels aren't weighted on a one-to-one basis. To that point, every time a sound goes up by 3 decibels, it effectively is becoming twice as loud. We've got a little list here of some of the different SPL levels, and you can see how they correspond to different things. We also use the decibel to measure the loudness of sound, and in terms of audio, it kind of refers to the signal level or the volume. And you'll see that when we're working with digital audio, we'll talk about turning a sound up a few dB or down a few dB. In the next movie, we'll take a look at hertz and frequency response.